All right, I want to write and solve an equation. I'm going to find the value of h so that the figures, these triangles, have the same area. Okay, well this is not too bad. The first thing I need to remember though, that the area of a triangle, so the area of a triangle, remember what that formula is? The area of a triangle is actually one half the base, times the height. So 1/2 base times height. In this case, it would be 1/2 10 times h minus 2. And in this case, it's 1/2 6 times h. All right, so let me actually work this out. I want to find an h that is going to make both of these equal. Well, I better first see if I can find the area of both triangles. So let's see. In this case, like I said, it was if the area of a triangle is 1/2 base times height, this triangle's area, the area would equal 1/2 base, which is 6, times the height, which we don't have a value for. We're just calling it h. And in this triangle, the area is going to equal the 1/2 the base. The base here is 10. And then 10 times what? Well, 10 times the height, which we are just told is h minus 2. Okay, I'll take their word for it and I'll just plug it in. Okay, I think I can actually simplify these a little bit. Let's see, a half of the quantity 6h, if I have 6 h's and I take half of those 6 h's, I end up with just 3 h's. So the area of this is just simply going to be 3h. And let's see, if I've got a quantity 10h minus 2s. If I take half of 10h minus 2s, I end up with 5h minus 2s. So 5, area equals 5h minus 2. Okay, so now let me set these. Looks like I've got this area for this triangle and this area for this triangle. Well, if I want to find a value for h so that the figures have the same area, let me set these areas equal to each other. So 3h, that's the area of this one, I'm going to set equal to 5h minus 2, or 5 times the difference of h and 2. That's the area of this triangle. Now, I can solve for h and find a value for h that makes this true. So hopefully you see that I need to distribute to break the h out of these grouping symbols. So I'm going to rewrite this side. 3h is equal to, let's see, 5 times h is 5h, and 5 times negative 2 is negative 10. Okay, now I'm going to subtract, and again, my goal is to get h on only one side of the equal sign and everything else on the other. I can move this 5h to this side by subtracting 5h here. And if I subtract 5h here, I need to subtract 5h from this side. Okay, let's see. 3h minus 5h, that's negative 2h. This eliminates, and I end up with just negative 10 on this side. Hopefully you see I'm going to divide both sides by negative 2. Let me actually fix that, make it look nicer. Negative 2, there we go. And let's see, this turns into 1h, just h, is equal to negative 10 divided by negative 2. That's a positive 5. All right, I think h is going to equal 5. How am I going to figure that out for sure? Can you guess what I'm going to do? Well, hopefully you guessed that I'm going to plug in h equals 5 into both areas and see if I get the same exact area. Let's see. So in this case, the area is going to equal 3h, or 3 times 5. That means the area equals 15. And in this case, I'm going to say, for this triangle, I'm going to say that area equals 5 times 5 for h here. So 5 times 5 minus 2. Okay, I need to simplify this. So that's going to be 5. I don't have to distribute because I don't have any variables in here. I can just do 5 minus 2. 5 minus 2 is 3. And 5 times 3 is 15. Well, would you look at that? Both areas, given this h equals 5, Both areas are equal to 15. Now, one thing I should probably say is it's 15 units squared. 15 units squared. Okay, so given if h is equal to 5, both of these triangles will have the same exact area. So my solution to this problem is h equals 5.